This is the Introduction to Trigonometry video. We're going to talk about trig ratios, reciprocal functions, and then do some examples. So the first thing that we need to talk about is an acute angle. An acute angle is an angle with measure greater than 0 and less than 90 degrees. So if you look at my triangle here, here is my 90-degree angle. And if you remember, all of the angles in a triangle have to sum to equal 180 degrees. So if I always have a right angle here, I'm going to have 180 minus 90 degrees, which equals 90 degrees. So if I have two angles located here and then another angle located here, these two angles are always going to be acute angles because their sum has to equal 90 degrees. So they're always going to be less than 90 degrees. So another thing we need to look at is the side adjacent and the side opposite of our angles. So if I'm looking at only this angle in the upper corner here, the side adjacent to that angle is going to be the side that touches that angle. The side opposite of that angle is going to be directly opposite to that angle. And our hypotenuse is always going to be the side that's opposite of our 90-degree angle. So if I look at my blank triangle over here, this time my angle is located in this bottom corner. So the side opposite of that angle is going to be over here. This is going to be my side opposite. My side adjacent is the one touching this angle, so this is my adjacent side. And then across from my 90-degree angle is always going to be my hypotenuse. Keep in mind that we use Greek letters to denote our angles: alpha, beta, gamma, theta, and sigma. Alright, so if you've already watched some of the previous videos, we looked at similar triangles. When we looked at similar triangles, we found that the lengths of the sides of the triangles are used to define the 6 trigonometric ratios. So if we let theta be our acute angle of our right triangle, as we saw in the previous slide, the 6 functions of theta are going to be defined as follows. Sine theta is going to be the side opposite of our angle over our hypotenuse. The cosine of theta is going to be our side adjacent over our hypotenuse. And tan theta is going to be our side opposite over our side adjacent. So we have come up with SOHCAHTOA. This is very widely used, and it's a way to help you remember sine, cosine, and tangent. So here I have sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So we will use these in the examples that we're getting ready to do in order to remember our sine, cosine, and tangent functions. So if we look over here, we have cosecant theta. Cosecant theta is the reciprocal of sine theta. So now we have hypotenuse over side opposite. Secant theta is the reciprocal of cosine. So now we have hypotenuse over side adjacent. And cotangent is the reciprocal of our tan function, which is now adjacent over opposite. Alright, so let's take a look at our first example. We always need to keep in mind where our angle is. So here is our angle theta. And just like I said, we're always going to use SOHCAHTOA in order to be able to find our 6 trigonometric functions, which is what it's asking us to do. So here's our angle, and so the first thing that we want to find is we want to find sine of theta. So sine of theta we said was opposite over hypotenuse. So here's my theta, my side opposite is 9, and my hypotenuse is 15. This is going to reduce down to 3/5. So sine theta equals 3/5. Now we need to find cosine theta. And we said that cosine theta is adjacent over hypotenuse. So my adjacent angle is 12 over my hypotenuse, 15. This is going to reduce down to 4/5, so cosine theta is 4/5. Now we have tan theta. Tan theta is opposite over adjacent. Opposite we said was 9, and my adjacent side 12. This is going to reduce down to 3/4. So tan theta is 3/4. So now I need to find cosecant theta, secant theta, and cotan theta. As we said, that secant theta is the reciprocal of sine. So since I've already reduced it right here, I can actually just take where I've already reduced it to and flip it. So I get 5/3. Secant theta is the reciprocal to cosine theta. So I can take my already reduced fraction again and flip that, 5/4. Cotan theta is the reciprocal to tan theta. So again, I can take that reduced fraction and flip it. And so here are the 6 trigonometric function values for my given triangle. All right, if we look at this next example, my angle is now located up here. So my side opposite of that angle is 4, and the side adjacent to that angle is 8. But we don't know what our hypotenuse is, so we need to find that. So if you recall the Pythagorean theorem, a squared plus b squared equals c squared, where a and b are the lengths of the sides of the right triangle and c is the length of the hypotenuse. So we can use the Pythagorean theorem in order to find my hypotenuse. So here I have the side opposite of my angle squared plus the side adjacent to my angle squared is going to give me my hypotenuse squared. So that's going to give me 16 plus 64 equals my hypotenuse squared. That's 80 equals my hypotenuse squared. So my hypotenuse equals the square root of 80, which reduces down to 4√5. So now I know my hypotenuse is 4 square root 5. So now that we have all of the sides of my triangle, we can now find the 6 trigonometric function values. Starting with sine theta, again we're going to use SOHCAHTOA. So sine is opposite over hypotenuse. We said the side opposite is 4, and my hypotenuse is 4√5. My 4's are going to cancel and leave me with 1/√5, but we don't want to leave a radical in the denominator, so I need to multiply both top and bottom by √5, and I get √5/5. So the sine of theta is √5/5. Next we need to find cosine theta. We said cosine theta is adjacent over hypotenuse. My adjacent side is 8 and my hypotenuse 4√5. This is going to simplify to 2√5. Again, not wanting to leave the radical in the denominator, multiplying top and bottom by √5 is going to give me 2√5/5. Okay, then tan theta equals opposite over adjacent. So my opposite is 4, my adjacent is 8, and that simplifies to 1/2. All right, next we need to find cosecant theta. Cosecant theta is the reciprocal to sine theta. So I can take what it originally equaled right there, 1/√5, and take the reciprocal of that, and I get √5. We need to find secant theta. Secant theta is the reciprocal to cosine theta. So again, I'm going to take this piece right here and get √5/2. Then last but not least, cotan theta is going to equal the reciprocal of tan theta, which gives me 2. So the reason I kind of chose to take this part of what sine theta equaled instead of my final answer is because if I take the reciprocal of this, you'll notice I get 5 over square root 5, which now means I have a radical in my denominator. I would then have to multiply top and bottom again by square root 5, and I would get 5 square root 5 over 5, and my 5's would cancel and I would still be left with that square root 5. So I kind of, in a very tricky way, chose to use this instead of my final answer only because I knew I was going to have to multiply top and bottom again by root 5. So in taking this one, I basically just made the work a little easier for myself. But it doesn't matter which answer for sine theta you choose to take the reciprocal of. You're still going to get the same answer. Alright, so this example is even more complicated because I don't have my triangle. And the only thing they gave me is cosecant of beta equals 1.5. That's the only piece of information I have to go on. Alright, so the first thing that I'm going to do is I'm going to rewrite cosecant of beta in fraction form instead of decimal form. This is going to give me 3 over 2. So we also know that cosecant of our angle beta is the reciprocal of sine. So if we recall SOHCAHTOA, we know that sine is opposite over hypotenuse. So the reciprocal is going to be hypotenuse over opposite, which we said was 3 over 2. So now I know my hypotenuse is 3, my side opposite of angle beta is going to be 2. So now I can draw my right triangle, choosing this angle to be angle beta. Here's my right angle. So across from my right angle is my hypotenuse, which we said was 3. Side opposite of beta is 2. So the side adjacent to angle beta is what I don't know. So again, we can use the Pythagorean theorem in order to find the side adjacent to angle beta. So we have side opposite squared plus the adjacent side squared equals the hypotenuse squared. Gives me 4 plus the side adjacent squared equal to 9. So a squared equals 5. So the side adjacent to my angle beta is going to be the square root of 5. So now that we have all the sides of my triangle, we can now find the other 5 trigonometric values. Sine of theta equals opposite 2 over hypotenuse 3. Cosine theta equals the side adjacent, which we just found to be root 5 over my hypotenuse 3. Tan theta, the side opposite 2 over adjacent root 5. Again, we don't want to leave that radical in the denominator, so multiply top and bottom by root 5, and I get 2 root 5 over 5. We already have cosecant theta, so we need to find secant theta. So secant theta is the reciprocal to cosine. So here's my cosine, and take the reciprocal of that, and I get 3 over root 5. Don't leave that radical in the denominator. So I get 3 root 5 over 5. And last but not least, cotan theta, the reciprocal to tan theta. So I have adjacent root 5 over my side opposite 2. Alright, so as we've been saying all along, Cosecant theta is the reciprocal to sine theta. Secant theta is the reciprocal to cosine theta. And cotan theta is the reciprocal to tan theta. So if you look over here, this is probably something that you haven't seen before. Tan theta equals sine theta divided by cosine theta. In a couple of sections, once I derive the unit circle, you'll actually be able to see how sine theta is actually the side opposite of our angle, and cosine theta is the side adjacent to our angle. So if that's the case for tan theta, when we look at its reciprocal, cotan theta, we're going to again flip these. So we end up with cosine theta over sine theta. So looking at this last example, we're given what sine theta is, cosine theta, and tan theta, and they want us to find cosecant, secant, and cotan of our angle. So here if we have cosecant theta, we know that that's equal to 1 over sine theta. And they gave us what sine theta was. Sine theta is root 5 divided by 3. And that's going to simplify to 3 root 5. But we don't want to leave that radical in the denominator. Multiply top and bottom by root 5, and we get 3 root 5 over 5. All right, secant theta is equal to 1 over cosine theta, our reciprocal function. We know what cosine theta is. They gave us 2/3, which simplifies to 3 over 2. And finally, cotan theta is equal to 1 over tan theta. And they said tan theta was root 5 over 2, which gives me 2 over root 5. Getting rid of that radical, I get 2 root 5 over 5. And so that's really all you need to know for your introduction to trig video.